Today, we are talking about the surface area and volume of cylinders, cones, and spheres. Now, none of these shapes, none of those three, cylinders, cones, and spheres, they are not polyhedra. That means that we can't apply the equations that we've already got for volume of a prism, volume of a pyramid directly to these shapes. However, these three shapes, specifically the cylinders and the cones, do behave exactly like polyhedron. And in fact, for cylinders and cones, we can use what we know about prisms and pyramids to develop the equations for them. Okay. So here on the screen there, you'll see that the picture on the left is representing a cylinder. So when we're talking about a cylinder, essentially what we're talking about is a prism that has a circular base. Now, it can't be considered a prism because the bases are circles, and prisms, all the sides have to be polygons. Circles are not polygons. So we have to have our own set of equations for cylinders, cones, and spheres because they're not polyhedra. So we cannot use the equations we developed previously. We can't use those equations, so we have to develop a new set. Now, the good news is that because a prism behaves exactly, or a cylinder behaves exactly like a prism, our equation for a cylinder are based on the equations for prisms. So we said before that the volume of a prism is area of the base times the height. Well, in a cylinder, the base is a circle. So instead of area of the base, what we would do is we would plug in the area of a circle. So instead of area of the base, what we're going to plug in here is pi r squared, which is the area of a circle. And then we include the height of the prism. And that's it. That's the equation for volume of a cylinder. Volume is pi r squared h, where h is the distance between those two circles, and r is the radius of that circle. That's a terrible R. Let's try that again. That's better. Okay. Now, no worries about sometimes people pop in and out. Not a big deal. All right. So, volume of cylinder. So I'll write it up here as just the equation is pi r squared h. Now, for lateral surface area would be the area of just the side of the cylinder. So over here we have the net of a cylinder. And the rectangle would be the lateral surface area. So the good news is that the one of the two dimensions of that cylinder is the height of the prism, just like it was, or the height of the cylinder, just like it was for prisms. Now, circles don't have perimeter. So instead of the perimeter of the base, we're going to insert the circumference of the circle. So instead of perimeter of the base, we are going to insert the circumference of the circle, which is 2 pi r. And then to that, we will add the height of the prism. So 2 pi rh. So the lateral surface area is 2 pi rh. Okay, because this length along here is the circumference of the circle, of the circular base, which is 2 pi r. Okay, and then finally we've got total surface area. Again, what we do for total surface area is we take the lateral surface area and we include the area of the bases. So that would be 2 of these circles. Well, the circles have a radius of r. So the area of one base, so we still have the 2 in there. So we're doing 2 times the area of the base, which would be pi r squared, just like it was in the volume, plus The lateral surface area, which we just got done saying, was 2 pi RH. So our surface area equation for a cylinder is 2 pi r squared plus 2 pi RH. These are our equations for cylinders. And those would only be for cylinders. So part of the challenge here in this lesson when we get into the assignment is going to be making sure that you're using the correct equations for each problem, because each of these three shapes, cylinders, cones, and spheres, has their own set of equations. So up there on the screen, you've got the volume, lateral surface area, and surface area equations. Those are for cylinders specifically. Okay, so we'll take a minute here. Does anybody have any questions before we advance to the next slide? We will get to that, Jasmine. We'll do both. We will use the pi symbol to give an exact answer, and then we will plug in 3.14 to get an estimated answer. We'll talk about that more when we get to examples, which we're actually going to do an example here on the next slide. Good question. Good question. And we will use 3.14, not the pi button, because that's what the SAT does. Okay. So hopefully you've at least had enough time to get a screenshot of this screen. I'll pause about another 10 seconds in case you haven't. If you don't have it written down, just grab a quick screenshot. You can get it later. And we're going to do a cylinder example. So we are asked here in this example to find the volume, the lateral surface area, and the surface area of this cylinder. Now we are going to give both an exact answer and an estimated answer, round to the nearest hundredth, for each of those. Okay, now there's a little bit of a trick to this, and that is that they did not give us the radius. They gave us the diameter. They told us two things here in this picture. They told us that the diameter is 28 inches, and they told us that the height of the cylinder is 26 inches. Now, in order to do these equations, we need to know the radius, not the diameter. So we need to remember that in any circle, if we're given the diameter, we can easily find the radius just by taking that diameter and dividing it in half. So if the diameter is 28, then the radius is 28 divided by 2, or 14 inches. Okay? So we have a radius of 14 inches, and we have a height of 26. We should be able to go straight into our volume equation, which is pi r squared h. Now, we are not going to plug in pi yet. We're just going to leave the pi in there, okay? The radius is 14 squared, and the height is 26. So ignore the pi symbol. Act like it is not there. Do 14 squared times 26. That is 5,096. So this allows us to give an exact answer for the volume, which would be 5,096 times pi inches cubed. This is our exact answer. It still contains the pi symbol. We have not done anything with that pi yet. Then, if we plug in 3.14 for pi, that will give us an approximate answer. So we do that, and that gives us an approximate answer of 16,001.44 cubic inches, which is going to be our approximate answer. I am going to ask for both of these answers on your homework assignment, both the exact and the estimated, the approximate. So what you do is you go in and you pretend like there is nobody or hold on one second, I got somebody in the waiting room. Whoa, oops, I hit caps lock. Oh, well, that was aggressive. All right, anyway. So you're going to be asked to give both. So please make sure that you give me both of those answers, the exact and the approximate. On to lateral surface area. The lateral surface area is 2 pi r/h. So same deal. We're going to ignore that pi symbol. Going to plug in the radius of 14. Plug in the height of 26. We're going to go in and we're going to do the 2 times 14 times 26 to give us an exact answer of 728 pi square inches. So again, that is our exact answer. And then if we plug in pi, or 3.14, and refeed that to our calculator, we get an approximated lateral surface area of 2,285.92 square inches. So again, I'm going to be looking for both the exact answer and the approximate answer for lateral surface area. Okay. So that brings us to total surface area, which is 2 pi r squared plus 2 pi r/h. Same deal, we're going to ignore those pi symbols at first and just plug in the radius and the height. And this one I'm going to show a little bit more work. In theory, you can type that into your calculator. If you use the pi button, what it will do is it will allow the exact answer to come out of your yellow calculators. Now, if you don't have a yellow calculator, you got to do it in 2 parts. That's why I'm going to show all the work now, so that if you don't have one of those yellow calculators, you can see how this works. So we do 2 times 14 squared gives us 392 pi for the first part. And we already know that 2 times 14 times 26 is 728 pi. We would add those two values together, 392 plus 728, and that would be an exact surface area of 1,120 pi square inches. So that's our exact answer. And then again, we are going to plug in 3.14 for pi, which gives us 3,516.8 square inches for our approximate surface area. So there we go. There's a cylinder example, and they don't get any harder than that, ever. So it's worth noting that that is as hard as these problems will ever be in this course. Any questions on that example before we move forward and talk about cones? Okay, once again, if you don't have all this written down, you may grab a quick screenshot. If you don't have time for that, don't worry too much. This video will be on YouTube as quickly as I can put it on YouTube after the meeting. Okay? So, we got our answers there, exact and approximate, for volume, lateral surface area, and surface area. So we're moving on to talk about cones next. Cones essentially behave like a pyramid with a circular base. So once again, we can base our equations for cones on the equations that we developed for pyramids. So since the volume of a pyramid is 1/3 times the area of the base times the height of the cone, we can look at this and say to ourselves, okay, the area of the base, since the base is a circle, that would be pi r squared. Okay, we talked about that earlier, that the area of the base, in this case it's a circle, so we would plug in pi r squared for that. So we leave the 1/3. For the area of the base, we plug in pi r squared, and we still have a vertical height for the cone. And that's where our equation for the volume of a cone comes from. The volume of any cone is 1/3 pi r squared h. It's supposed to be an r, and it doesn't look like one, so I'm going to try again. R squared h. Where again, the radius is the radius of the circle. The height is the vertical height of the triangle. And then we've got that one other measurement there, the slant height, that we'll be dealing with in surface area. Okay? So 1/3 pi r squared h is our volume equation for a cone. On to lateral surface area. This one doesn't really, it doesn't fit quite as well. The explanation at least doesn't, because if you look at the net of a cone, that the side of the cone, you would think it's a triangle, but it's not. It's actually a sector of a circle. So the lucky news is that it does still behave the same way, but it doesn't make as much sense as the cylinder did when you just look at the net. Okay, we still are doing the same basic idea here. We're going to plug in circumference for perimeter of the base. So we've got that 1/2 in there still. And then for the perimeter of the base, we plug in our circumference, which is 2 pi r. And then we still have the slant height. Well, if we look at that equation, the 2 and the 1/2 actually will cancel each other out. So the 2 and the 1/2 cancel, and we're left with pi times the radius times the slant height. So the lateral surface area of any cone is pi times the radius times the slant height, L. Okay, finally, we've got surface area. So for regular surface area of a pyramid, that would be the lateral surface area plus the area of the base. So for lateral surface area, the area of the base is a circle. That would be pi r squared. And we just established that the lateral surface area reduces to pi r L. So our surface area equation is going to be pi r squared plus pi r L, where L is the slant height of the pyramid. So again, we've got a whole set of equations that are specifically for cones. These are our cone equations up at the top. Okay? All right. So those equations up at the top there, those are your cone equations. Please grab a screenshot. If there are any questions, drop them in chat. Otherwise, we're going to be moving on to the next page, which is a cone example here in about 15 seconds. Yes, yes, Aiden, that is pi times the radius times the slant height for the lateral surface area, pi RL. Okay. So let's do a cone example. Here is an example of a cone being asked to find the volume, the lateral surface area, and the surface area of this cone. So we have everything we need already given there. We don't need to do any work up front. We've got the height is 48, we have the slant height is 60, and we have the radius is 36 centimeters. So we can go straight into finding the volume. again, the volume, and I just wrote that wrong already, is 1/3 pi r squared h. So we do the same thing we did for the cylinder. We leave the pi symbol in there for now and ignore it. So the radius is 36, and we're squaring that, and the height is 48. So into our calculator, we're going to feed 1/3 times 36 squared times 48, which is a pretty big number. That would be 20,736 pi cubic centimeters. And again, this is our exact answer. Okay, so I am going to ask for the exact answer. So there's the exact answer for the volume. Then we're going to find the approximate answer by taking that number, 2,736, and multiplying it by 3.14 for pi. So times 3.14. That would give us an approximate volume of 65,111.04 cubic centimeters. Again, I will ask for both. That volume equation applies to all cones. Yes, all cones. Again, cylinders have their own equations, cones have their own equations, and spheres are their whole singular animal. They're completely unique. Okay? So on to lateral surface area, which we said was pi times r times the slant height. Same deal, we're just going to plug in the radius and the slant height for now, and we're going to multiply those together. That doesn't look like 60, so let me rewrite that. So 36 times 60 would give us 2,160 pi square centimeters for our exact lateral surface area. And then once again, we're going to find the approximate lateral surface area by plugging in 3.14 for pi. So 2160 times 3.14 gives us an approximate lateral surface area of 6,782.4 square centimeters. And I will be asking for both. Okay, that brings us to our final information that we need to provide here, which is the surface area. Again, our equation for that is pi r squared plus pi r L. So again, we're just going to plug in those numbers, pi r squared plus pi r L. And we're going to simplify that down to a single number. So we would start with squaring 36 is 1,296 pi. And we already know that 36 times 60 is 2,160 pi. So we would add those together, 2,160 plus 1,296 is 3,456 pi square centimeters, which is our exact surface area. Depends on what calculator you have. If you have the yellow calculator, you can put it in with the pi button to get the exact answer, but then you'll have to plug in 3.14 to get the correct approximated answer. Then for the approximate answer, we're going to multiply 3,456 times 3.14, which is approximately 10,851.84 square centimeters. That's our approximate answer. So that takes care of surface area, lateral surface area, and volume for this cone. There's our example. Again, I'm going to be asking you to provide both the exact answer and the approximate answer. If you have the yellow calculator and you type in the equation with the pi symbol, it will give you the exact answer. What you will then have to do is you will have to go back and take your exact answer and substitute 3.14 for pi to get the approximate answer. Because if you just convert it, your approximate answer will be too good of an answer, if that makes sense. No, I'm fairly certain I'm not. I do not have a help session today, no, at least not for geometry. We could probably work out a time later if you have questions, so email me. Okay. So again, if you haven't had time to get all that down, grab a screenshot real quick. Also, don't worry too much. This video will be up about 15 minutes after we finish the lesson. We need to move on and talk about spheres. We're starting to push our luck here on how long we're spending on Zoom. So that's our cone example. Our last shape we're talking about in this unit is spheres. Spheres are very unique in that they don't really fit the mold of any other geometric shape. And if we had more time, if we were in the classroom and we could actually toy around with these a little bit, we would develop these equations in an entirely different way. But since we're distance learning, I'm going to provide you with the equations for volume and surface area of a sphere. I'm unfortunately not going to be able to give you a lot of the explanation as to why these are the equations. But really, what's most important here is that we know how to find the volume and the surface area of a sphere. So for volume, in a sphere, spheres only have one measurement of note, and that is a radius. All we really care about in the sphere is a radius. They don't have a height. They don't have a slant height. They just have a radius, because every point on that sphere is located the same exact distance away from the center of that circle as every other point. They're not coplanar, but they're all points that are equidistant from that center. So the only measurement they have that we care about is the radius. The volume of any sphere is 4/3, and I know that's an odd fraction, times pi times the radius cubed. So 4/3 pi r cubed. Now, in addition, spheres don't have lateral surface area because the sphere is one rounded face. I can't really call it a face because it's not a polyhedra, but it's just one surface. There aren't any breaks anywhere in that surface. It's a smooth surface where every point is the same distance from the center. So we don't have a lateral surface area. We only have volume and surface area. And the surface area of any sphere is equal to 4 times pi r squared. So that's all we have to do there is take 4 times pi r squared. And again, I wish that there was an easy way for me to give you the same experience with spheres that we would have had in the classroom, but there just really isn't. So I'm hoping you're willing to take my word that these equations are correct and not worry too much about where they come from right now. Those of you that eventually make it into a calculus class, you will see where these come from. I wish I could give you a better explanation. So we've got those two equations there. These are for spheres. Again, spheres do not have a lateral surface area, just a volume and a surface area. So down below we have an example of a sphere. You're asked to find the volume and the surface area. Same deal. We want an exact answer and an approximate answer. So first things first, we need to find the radius. If the diameter is 84 millimeters, then the radius is half of that, or 42 millimeters. Again, anytime I give you one of these problems and I give you a diameter, that should just barely slow you down. Because if you know the diameter, the radius is really easy to find. Okay, you just take the diameter divided by 2, boom, you got the radius.
So our volume is 4/3 pi r cubed. Same deal, we're going to leave that pi in there, plug in the radius,
and cube it. So we have 42 to the 3rd power times 4/3. Which is 98,784 pi. Units are millimeters cubed. Then we are going to find our estimated answer by plugging in 3.14 for pi, which gives us an approximate volume of 310,181.76 millimeters. Boy, that is a terrible M. Let's try that one more time there. Millimeters cubed. So there's our exact answer, and there's our approximate answer. For volume. That just leaves surface area. Okay. So once we have the volume, then we turn our attention to surface area. Surface area is 4 pi r squared. That is 4 pi times 42 squared. So 4 times 42 squared would be 7,056 pi millimeters squared. And then we take that times 3.14 to get the approximate surface area, which would be 22,155.84 square millimeters. So again, there's our exact, and there's our approximate. Okay, so that does it for our lesson. Anybody have any questions on spheres before I got one more page. I have one more page of notes. That does it for spheres. Anybody have any questions before we go over the last little details? Just drop them in chat. Again, you can take a screenshot if you don't have anything written down yet. The video will be up probably by about 12:10 today, so pretty quickly after the lesson. Nobody's jumping on the opportunity. Okay. So a couple little details to keep in mind here. Okay, we're always going to give an exact answer based on pi, and an estimated answer where we let pi be equal to 3.14. And again, if I give you a diameter, you find the radius by dividing by 2. Dividing by 2. So just real quickly, I want to put it all in one place here. We had 3 shapes that we talked about today: cylinders, cones, and spheres. The volume of any cylinder is equal to pi r squared h. The lateral surface area of any cylinder is equal to 2 pi r h, and the surface area of any cylinder is equal to 2 pi r squared plus 2 pi r h. For cones, the volume of any cone is 1/3 pi r squared h, where h is the vertical height. The lateral surface area is equal to pi times the radius times the slant height, or pi RL.
And the surface area is equal to pi r squared plus pi r L. Finally, spheres, volume is 4/3 pi r cubed. Surface area is 4 pi r squared. And there is no lateral surface area in a sphere. So there are our equations for cylinders, cones, and spheres all in one place. Again, when you're doing the assignment, please make sure you are using the correct equations based on the figure, the shape that you're looking at. Okay? All right, I'm going to stop the recording because that finishes up our notes. So here we go.